Lesson 12, the two phases of the premium of an option. Here what you will learn here. How does the market form option prices, intrinsic value and time value, value at now versus value at expiry. From the observation of the option chain, now a very important question could arise. How does the market determine the price of each listed option? Let's go back to the option chain and do some reasoning. In the moment the underlying price is 17,680 points, what can we say about the call 17,000? Just to make an example. That since it gives the right to purchase the FTSE index for 17,000 points when it is valued 17,680, what should be at least the price of this option? 680 points. The evaluation of the real advantage it carries. Indeed, to have the right to purchase for 17,000 points something valued 17,680 would provide the buyer an immediate advantage valued 680 points. Assume that you purchase this call and you can exercise it right away. You buy it, you exercise it, you get a sign of one FTSE index for 17,000 points. Then what? Then you sell it in the market for 17,680. It's an immediate advantage, an immediate gain of 680 points. So that is for sure the minimum value of that option. But why is the price 1,370? Because we do not just have to deal with the difference between the spot price and the strike price. There is also 64 days left for other events to happen. It means that the underlying could keep going up, it could remain still, it could come back, drop. So the price of an option today has to account not only for the real value of the option, but also for the expected future value of that option. And here we go to the distinction between intrinsic value and time value. First of all, let me say that the premium of an option is always given by the sum of two elements, the intrinsic value and the time value. The first one, which we indicate with IV below, is given by a simple mathematical formula. Pay attention, it's just a matter of math. The intrinsic value of a call, it's the maximum between 0 and the difference between spot and strike. So let's go back to the chain and see what all of this implies. A call 17,000, which is in the money, has to be valued the maximum between 0 and 17,680 minus 17,000. In this case, 680 points. At least, this is the intrinsic value, the real value. Call it the real value of the option. What about the call 18,000? The call 18,000 has to be valued at least the maximum between 0 and 17,680 minus 18,000. 17,680 minus 18,000 makes minus 320. But the premium of an option cannot be negative, so it's set arbitrary to 0. That's why the maximum between 0 and spot minus strike. So, the intrinsic value of a call, it's the maximum between 0 and spot minus strike. This means that in the money options have an intrinsic value. Out of the money option have a negative intrinsic value, which means it's 0. For the puts, it's the opposite. It's the maximum between 0 and strike minus spot, because puts are in the money when the spot is below the strike. The intrinsic value is, in a certain sense, the true value of the option, positive only when the strike has been reached and exceeded, upwards for calls, downward for puts. According to the formula, it can never go below 0. Therefore, an option can never assume a negative intrinsic value. It's a feature set by the contract, as we have already said a few lessons ago. Example, if the spot is 20 euros, all the calls with a strike equal to or greater than 20 at the money or out of the money have 0 intrinsic value. The 19 call has an intrinsic value of 1, the 18 call has an intrinsic value of 2, and so on. A very important note, the intrinsic value is not affected by the expiry. This means that if the spot price is 20, the 18 call, for example, has an intrinsic value equal to 2 no matter how far the deadline is. The time value, TV, is the component that is added to the intrinsic value to determine the total premium of an option. In general, the time value represents how much investors are willing to pay for the expectation that the spot price will move in a specific direction by a certain future date, and sufficiently to reach and exceed a given target price. It is therefore the expectation price that the intrinsic value of the option will be positive at maturity. Time is then a key variable for options. The longer the time available, the greater the probability that the price of the underlying moves also considerably compared to the starting value. As time passes, therefore, the time value is reduced, since the probability that the underlying moves in a specific direction and of a certain entity is progressively reduced. Example, if a share is worth 20 euros and the call strike 19 and maturity in 6 months quotes 125, 1 is the intrinsic value, 20 minus 19, but the difference, 25 euro cents, is time value. If the deadline is not 6 months but greater, say 12 months, then the intrinsic value is still 1, but the time value is greater, let's say 0.40. So the option price is 140 instead of 125. Time value depends on the trend of different variables. We will deal with it shortly. The trend of the time value and the intrinsic value is obviously not constant over time, since everything depends on how the spot price moves with respect to the strike. All out-of-the-money options have no intrinsic value, and their price is made up only of time value. But when the spot price rises above the strike, the premium becomes a combination of the two values. But things are more complicated than they seem. If the spot overcomes the strike too late, it may be that the appreciation in terms of intrinsic value is less than the depreciation of the time value caused by the passage of time. It can let the option lose value even if the underlying goes in the right direction. And this is another, let's call it, drawback of being buyers of options. Let's go back to the chain in order to better understand this. Here, the call 17,000 can be purchased for 1,370, but the real value of this option is only 680. So this means that the market expects that within the next 64 days, the price of the underlying will go even higher than 17,680. But what if the market is wrong? What if at maturity the price of the underlying is still 17,680? At maturity there will be no longer time value to be taken into account. So what will be left will be only intrinsic value, 680 points. So who purchased the call 17,000 expecting that the index would have crossed 17,000 was right, because it's 17,680, but they are still losing money because they paid 1,370, something that now is valued only 680. And this happens even if the price of the underlying at maturity is 18,000, because if the underlying at maturity is 18,000, the call 17,000 will be valued 1,000 points, meaning that if you purchased it for 1,370, you will lose 370 points. So the conclusion is that you do not just have to be right about the fact that the price of the underlying will cross the strike price. You need it to cross at least the break-even point. And in the moment that you purchase the call 17,000 for 1,370 points, you need the underlying at expiration at least 18,370, or you will lose at least a part of the premium paid. So once again, if you are a buyer of an option, it could paradoxically happen that you're right about what happens to the underlying, and still you lose money because the movement in the underlying is not enough to cover the expense you suffered to buy the option. The intrinsic value can be zero long before the maturity, while the time value can be null only at maturity. For this reason, even very out-of-the-money options have very low but not zero prices. Indeed, they have no intrinsic value, and their probability of becoming in the money is very low, but it is not zero, so their price is not zero. On the other hand, at maturity, time value is zero by definition, so it remains all and only intrinsic value. Example, say a stock quotes 20 euros and the 21 euro call strike that expires in 3 months is worth 0.3. It's all time value because the intrinsic value is zero. In order to gain at maturity, we need the spot price to go up and cross 21 euros. So far, it is lower, so there is no intrinsic value. If the spot at maturity is 22, the call is worth 1, and it is only intrinsic value, because at maturity, the value of time is 0. If the spot at maturity is worth 20.5, the call is worth 0, because both components of the premium are 0. In the world of options, nothing is certain apart from their value at maturity given a certain spot price. If you purchase a call 20 and at maturity the spot price is 30, the value of the option will be for sure 10 euros. You cannot make mistakes about it. The final value is given by the intrinsic value only, so it is only a problem of distance between spot and strike. The serious problem with the options arises from the management of what happens before the expiry, since the dynamics in the prices of options can sometimes be very complicated to understand. The first concept it is important to take confidence with in order to understand how these dynamics work is the at-now curve. The following is the image of the at-now curve of a call strike 10 compared to the value line of the same option at maturity. This one is the value of the option at maturity. For any price of the underlying equal or lower than 10, the call 10 is valued 0. Then, if the spot crosses the strike, for every euro of increase, the option will be valued 1 euro. 1 euro, 11 euro, 1 euro, 12 euros, 2 euros, 20 euros, 10 euros, the value of the option. Spot minus strike. What happens today if there are 20 days, 50 days, 60 days, 100 days till the maturity is given by the at-now curve. But the at-now curve, which expresses what will be the price of the option if today we are at 10 and within, let's say, 2 hours, the price of the underlying is 11, it's only an estimate, because the price of the option in that moment will be a function of 6 parameters, some of which cannot be forecasted exactly. The slope of the at-now curve is the delta of the option, one of the Greeks we will see later on, equal to the first derivative of the option price with respect to the spot. In fact, it is a first partial derivative of the price curve. This is for mathematicians, of course, as this is the function of 5 variables or 6 if we're talking about stock options and there are dividends to be taken into account. And the price is just one of the 6 variables. A complication is given by the fact that the shape of the at-now curve is not constant, since it depends on how the other parameters that affect the price of the option move. The only certainty is that the at-now curve at maturity coincides with the broken line of the value at maturity. What happens is that day after day, the at-now curve gets very close, very close, very close, very close to the final value at maturity. And the day of maturity, this will be the at-now curve. So far, that's all. Thank you for your attention.